Hello bachcho, let's read this question. Hydrogen atom in its ground state is excited by means of a monochromatic radiation of wavelength 970.6 angstrom. Different wavelengths are possible in this spectrum. Now, after absorbing the energy of radiation, hydrogen atom goes to excited state, and after 10 raised to the power minus 8 seconds, the hydrogen atom will come to the ground state by emitting the absorbed energy. We have to find the value of energy absorbed by this hydrogen atom. So students, इस क्वेश्चन में हमें एक हाइड्रोजन एटम दी गई है. Let's say this is the hydrogen atom, and then इस पर एक 970.6 की रेडिएशन डाली जाती है. अब इस रेडिएशन से क्या होगा स्टूडेंट्स? दिस इलेक्ट्रॉन will absorb some of the energy of this electromagnetic radiation, and then after absorbing energy, this will jump to the higher energy level. Let's say it is jumped to nth energy level, and then first gaining stability back, it again loses the energy. So students, हमें ये बताना है कि इस इलेक्ट्रॉन ने इलेक्ट्रोमैग्नेटिक रेडिएशन से कितना एनर्जी एब्जॉर्ब करा था. For that, please note the key concept of this question. Which says the radiation carries energy with them, and the energy carried by a radiation of wavelength lambda is given by energy equals to hc upon lambda, जहाँ पर h is a Planck's constant, c represents speed of light, and lambda is the wavelength of radiation. So students, every radiation carries energy, and this energy is given by E equals to hc upon lambda, where lambda is wavelength of radiation. So students, जब 970.6 वेवलेंथ की रेडिएशन इस इलेक्ट्रॉन पर गिरी थी, then this electron will absorb some energy and jump to higher energy level. So student, इसने उतनी ही एब्जॉर्ब करी होगी एनर्जी जितना ये इलेक्ट्रोमैग्नेटिक रेडिएशन अपने साथ एनर्जी कैरी कर रहा है. फॉर दैट वी कैन राइट एनर्जी एब्जॉर्ब equals to hc upon lambda. On substituting the value of h, this is Planck's constant, 6.62 into 10 raised to the power minus 34. C is the speed of light, and this is lambda. So students, on substituting these values, we will get energy in joule. Energy in electron volt, we must divide these terms with 1.6 into 10 raised to the power minus 19 electron volt. And this lambda we can substitute here, 970.6 into 10 raised to the power 9 minus 10. Minus 10 because it was in angstrom, and we have to convert this angstrom into meters. So students, on solving these terms, we will get the expression of energy as 12,415 electron volt upon lambda, this is 970.6. We did this because we can directly substitute the value of lambda, that is we can generalize this formula 12,415 electron volt upon lambda, where lambda is in angstrom. So students, instead of solving these questions with substituting h, c again and again, we directly generalize this formula, that is E equals to 12,415 upon lambda. Now this value of energy will be given as 12,415 upon 970.6 electron volt. On calculating, this will come out to be roughly equal to 12.8 electron volt, and this corresponds to option D of this question. So the only correct option of this question is option D. I hope आपको ये concept समझ आए students. Thank you.